Welcome back to my channel JBR online classes. Please subscribe my channel and press the bell icon.
Hi everyone, in this video we will continue with the chapter number 2 exponent. Okay, so this is problem number 5. Here you need to express each of this term as a power of 2. So 8 equal, that means each of this term of 8 you have to write is as power of 2 to the power something. Similarly this also, so 8 equal to, so 8 you can break it into 2, then so 2 into 2 into 2, that is 8. So 8 equal to 2 power 3. 3 times if you multiply 2, then you got 8. Okay. So 8 to the power x. Now we already know that 8 equal to 2 cube. So just put the value 2 cube whole to the power x. Now here you can apply the formula number 2. So power of power. So 2 to the power 3 into x. That is the answer. Similarly, 16 to the power x plus 3. X plus 3 is the exponent. Okay. Now 16, if you just write, so 2 and then 2 into 2. So 4 times if you multiply 2, then you got 16. So 2 power 4 is 16 and this exponent is already there. Again, formula number 2. So it is going to be 2 to the power 4 into x plus 3. So you are getting 2 power 4x plus 12 and you are done. So this is problem number 6. Here A and B both are given and you need to show this. Now, so you just put the values of A and B in this left side of this expression. Okay. So 8 A cube by B square is equal to 8 of A's value is 2 to the power m whole cube divided by 2 power m plus 1 whole square. Okay. Now here you can just apply formula number 2. So 2 power 3m and then here also 2 power 2 into m plus 1. So 2m plus 2. Okay. Now here you can apply formula number 5 because these so this is a division and the base are same 2 and 2. Okay. So 8 is multiplied here and then it is 2 to the power 3m minus 2m minus 2. So if you just calculate 8 into 2 to the power m minus 2. Now we already know that 8 is 2 cube. So you just put it 2 cube into 2 to the power m minus 2 and then here you can apply formula number 1 because base are same. Okay. And these exponents are different. So 3 plus m minus 2. So 2 to the power 3 plus m minus 2 and you get 2 to the power m plus 1. See, so this is problem number 7. Now x and y both are given. You need to find x by y. Okay. Now x by y is 2 power k divided by 2 power k plus 3. It is very easy. So you just need to apply formula number 5 because base are same and powers are different. So 2 to the power k minus 3. So k this and then you just calculate k will get cancelled and 2 power minus 3 will be there. So it is a negative exponent. So finally 1 by just apply the formula of negative exponent 2 cube. So the final value will be 1 by 8. So this is problem number 8 part 1. Here you need to write each of this expression such that no variable in the denominator. Okay. Now here for this part 1 the variables are r and s, not 3 and 12. They are constants. Okay. So what you can do first, 3 4s are 12. So it is going to be 4. Okay. 4 can be in the denominator. Okay. So we don't need any variable in the denominator. Okay. Now for this term and this term, see, you can apply the formula number 5 because bases are equal and the powers are different. So r to the power minus 2 minus of minus 3. So minus 2 minus of minus 3. Okay. And for these two terms, same formula can be applied because bases are same and powers are different. So s to the power 3 minus 7. Okay. Now finally, so it is minus and minus plus and then it will be 1 only. And for s to the power 3 minus, so s to the power minus 4. divided by 4. So this is the answer. So this problem is again like the previous one. This is part 2. Okay, here 6 2s are 12. So 2, and then here for this term and this term, base are same, powers are different. So apply formula number 5. So x to the power 3 minus 7. For these two terms, y and y, base are same. So you can apply formula number 5 minus 2 of minus 5. So it is plus. Okay, and for this z, this term and this term, base are same. So same formula, 4 minus of minus 3. So it is plus 3. So ultimately the answer is 2 x to the power minus 4 y to the power y cube and then z to the power 7. So it is part 3. Now here 0 exponent is present, 5 to the power 5m to the power 0. So anything to the power 0 is 1. So first you put 1. So 1 into this, that means n to the power minus 2, 4 m n to the power minus 3. Now here see 1 by 4 can be there. Okay, so it is just there. So you just left it, and then for this m, 1 by m, that means m to the power minus 1 we can write, because this is a negative exponent. So if you just apply the formula of negative exponent on m to the power minus 1, you get 1 by m. So we can also say that 1 by m equal to m to the power minus 1, because we don't want m in the denominator. Okay, and for this quantity n and n to the power minus 2 and n to the power minus 3, you can just apply formula number 5. So n to the power minus 2 minus of minus 3, so plus. So final answer is 1 by 4 m to the power minus 1 n. This is part 4. Now 7 2s are 4. Okay, no, sorry. 7 to the power 0, anything to the power 0 is 1. So it is 14 only. Okay, and here base are same. So formula number 5. So a to the power minus 4 minus 3, and then here also for this term and this term, base are same. Here the exponent is 1. Okay, so 1 minus 8. So k to the power 1 minus 8. So final answer is 14 a to the power minus 7 k to the power minus 7. This is problem number 9 part 1. Here you need to simplify. So one hint is given that you express each and every term in terms as a power of 2. Okay, so that means 8 as a power of 2, 16 as a power of 2, 4 as a power of 2. Okay, now we already know that 8 is 2 cube and 16 is 2 to the power 4. Similarly 2 square is 4, 2 into 2 is 4. Okay, now 2 to the power minus m, I am just leaving it because it is already a power of 2. Okay, now instead of this 8, I am writing 2 cube. So 2n plus 1 and 2 to the power 4, 2n. Okay, 2 square whole to the power 3n. Okay, now here in this term you can apply formula 2. Here also you can apply formula 2, because power of power, power of power, and here also power of power. So you just multiply the powers. So 2 to the power minus n is already there. 2 to the power 3n, 3 into 2n plus 1. So 6n plus 3 and 2 to the power 8n, and then 2 to the power 6n again. Okay, now here in this numerator all the bases are 2. So you can just add the exponent. It is formula number 1. So 2 to the power minus n plus 6n plus 3 plus 8n divided by 2 to the power 6n. Now this numerator is 2 power 6 minus n is 5. So 13n plus 3 divided by 2 to the power 6n. Now again, sorry, 2 to the power 6n. So the bases are equal, which is 2. So you can apply formula number 5. So 2 to the power 13n plus 3 minus 6n. So it is going to be 2 to the power 7n plus 3. That's the answer. This is problem number 9 part 2. Okay, here you first observe this term, that here bases are equal and power is 1 and n. So you can apply formula number 1, a to the power m into a to the power n. Similarly here in this denominator also you can apply the formula number 1. Base are same, powers are different. So you first apply that. 2 to the power n plus 4 is there. So 2 to the power 1 plus n. Okay, and then here in the denominator 2 to the power 1 plus n plus 3, so n plus 4, and this 2 to the power minus 3 is already there. Okay, now I am just dividing this denominator in each of this term. So this by this minus this by this. Okay, so if you do this by this, both the terms are same. So it is going to be 1 minus this by this 2 to the power 1 plus n divided by 2 to the power n plus 4 and plus 2 to the power minus 3. It was already there. Now 1 minus, here the base is same and division is there. So you can apply formula number 5. Okay, so 2 to the power 1 plus n minus 4, 1 plus n minus n plus 4. So that is this, and then 2 to the power minus 3. So it is going to be 1 minus 2 to the power n will get cancelled, and 1 minus 4 is minus 3 plus 2 to the power minus 3. Now here you see this is minus 2 to the power minus 3 plus 2 to the power minus 3. So it will get cancelled, and finally it is going to be 1. This is problem number 9 part 3. Now here, so this is 0 exponent. First you put 1. Okay, and then this is negative exponent. So here you take this as one term. So it is going to be 1 by 0.1. Okay, now for this term also, this is negative exponent. So you take this term as one term and apply the negative exponent formula. So it is 1 by 3 by 2 cube, and this term is there. You just leave it for the time being. And then this is also negative exponent. So this is one term, you consider it and then apply that formula. Is it fine? Now 1 minus 1 by 0.1, it is actually 1 by 10. That means it will get flipped. So it is going to be 10. Is it fine? 0.1 is 1 by 10. So 1 by 10 present in the denominator. So it will get flipped. So it is 1 minus 10. Okay. Now here also this is present in the denominator for this term. So it will get flipped. So 2 to the power 3 divided by 3. 2 cube by 3 and then 3 by 2 whole cube. Okay. Now this also it will get flipped. So minus and plus, this will get minus, and it 1 by 3 it will get flipped. So 3. Okay. Now in the next line you can write it as, so it is 9 minus 9, and this is equal to 2 cube by 3, and here for this term you can apply formula number 4 because a by b whole to the power m. This is kind of the form. Okay. So 3 to the power 3 and then 2 to the power 3. So 3 to the power 3, 2 to the power 3, and minus 3 is already there. So it is minus 9 divided by 2 cube will get cancelled. Okay. So it is only 3 cube by 3 minus 3. Okay. Now it is minus 9, and then so here base are same and exponents are different and division is there in between these two terms. So 3 to the power 3 minus 1, it is formula number 5. So finally we are getting 3 square. 3 to the power 3 minus 1 means 3 square. 3 square is 9 minus 3. So it is minus 9 by 6 minus 3 by 2. That's the answer. So this is problem number 11. So see part 1. Okay. Now here you see this term in the bracket. Here you can apply formula number 5. Okay. Because base are same, division is there and powers are different. Okay. Similarly, this term in the bracket also you can apply formula number 5. Similarly, here also you can apply the same formula. So you first apply that. Now this LHS, this is equal to x to the power a minus b, that is the formula, and a plus to the power a plus b is already there, into x to the power b minus c by the same formula, and into x to the power c minus a by the same formula, and to the power c plus a is also there. Now this is power of power, power of power, and power of power. So apply formula number 2 in each of this term. So it is going to be a minus b into a plus b. It is a formula of a square minus b square. So a square minus b square. Similarly, b minus c, b plus c. So x to the power b square minus c square. Here also c square minus a square. Isn't it? So all the bases are equal. Now you just add the powers. So x to the power, this is formula number 1. X to the power a square minus b square plus b square minus c square plus c square minus a square. Okay. Now this a and this a will get cancelled. This b will get cancelled. This c, they are get cancelled. So finally it will be x to the power 0. The power is 0. So it is a 0 exponent. So it is going to be 1. It is proved. Problem number 11 part 2. Now here the left hand side is equal to, so first you can see that in the numerator all bases are same, that is x. So here you can apply formula number 1. So you just have to add the powers. So x to the power a plus b plus b plus c plus c plus a. Okay. Now for this denominator, here in this bracket, this term, okay, not this square. So for this term also the bases are same, x, x and x. So here also you can apply the same formula. So it is going to be x to the power a plus b plus c. Okay, formula number 1, and square, whole square is already there. So you just write it. Now here you just add it, a plus a, b plus b, c plus c. So it is going to be x to the power 2a plus 2b plus 2c. And here it is a power of power, so you just multiply by formula 2. So it is going to be x to the power 2 into a plus b plus c. So 2a plus 2b plus 2c, both the terms are same, so it is going to be 1. So this is problem number 12 part 1. Now here you can see that whenever so here you need to find this x. Okay, now whenever you are asked to find x and this kind of equation is given, you do like this, that in the left hand side you try to bring a base, as well as the same base you try to bring in the right hand side. So it is like the following. So see here in this left hand side 7 by 4 and this is also 7 by 4. So I am considering this 7 by 4 as one term. So for this term and this term the base are same and powers are different and multiplication is there. So I can apply formula number 1. So here it is 7 by 4 whole to the power this plus this. So minus 3 plus minus 5 is minus 8. Okay, and then 7 by 4 whole to the power 3x minus 2. Is it fine? Now whenever see in the left hand side 7 by 4 is the base, in the right hand side 7 by 4 in the base. Okay, so now I can just compare the powers. So straight away I can write minus 8 equal to 3x minus 2. Okay, and from here you can just find out the value of x, which is 3x equal to, so this will go to this side and this will be minus 6. So x will be minus 2. So this is problem number 12 part 2. Now here in this left hand side again you need to find x. Okay, so in the left hand side this is one term and this is one term. So these two base is 125 by 8. Okay, both are same. Here the power is 1. So I can apply the formula number 1 again. Okay, so by that formula 125 by 8 whole to the power, you just add the exponents. So this will be the next line. Okay, now here you can see that here the base is 5 by 2 and here the base is 125 by 8, but you need same base to compare these powers. Okay, now here you watch that 125 you can write it as, so 125 is actually 5 then 5 5. So 5 into 5 into 5, that is 125. So 5 cube. Okay, and this 2 we already know that 2 cube is 8 is 2 cube. Okay, and already to the power 1 by x is there, and this is the right hand side. Now here you can apply formula number 4. Okay, it is actually of the form a to the power m divided by b to the power m. So you can write, so you can just take this power common. So 5 by 2, okay, then whole cube, then whole to the power 1 by 1 plus x, and 5 by 2 whole to the power 18. Now it is a power of power, so apply formula 2. So 5 by 2 you just multiply 3 and 1 plus x, so 3 plus 3x, 5 by 2, 18. Sorry. Now you can see that both the bases are same, so you can just equate the powers. So therefore 3 plus 3x equal to 18. So from here 3x equal to 15, x equal to 5. This is problem number 13 part 1. Now here I am going to use a trick. So here also you need to find the value of x. Okay, so I am writing this left hand side as it is, and then this is 1 by 27 to the power x minus 3. So I am going to take 1 minus common from this power only. Okay, so if you just take minus common, so it will be 3 minus x, isn't it? Now this is a negative exponent, okay, because minus is there and negative exponent is present in the denominator. So you can straight away write that 1 by, not 1 by, it is going to be 3 to the power 2x minus 1 and then 27 to the power 3 minus x, okay, by the formula of a negative exponent. Now 3 to the power 2x minus 1, again it is there. Now 27, we know that 3 cube is 27. 3 into 3 into 3, that is 27. So 3 cube we can write, because we need same base in the left hand side as well as in the right hand side, isn't it? That's why I am writing this 27 as a power of 3. Okay. Now 3 to the power 2x minus 1 again, and this power of power, that means these two powers will get multiplied. So 3 to the power 3 into 3 minus 1, that is 9 minus 3x. Okay. So the bases are equal now. Now you can just equate these powers. So therefore 2x minus 1 equal to 9 minus 3x. From this, so 5x equal to 10, x equal to 2. That is the value. This is problem number 13 part 2. This is the last problem of this exercise. Okay. Now here also you need to find the value of x. Okay. Now here also I am going to apply a trick. Okay. It is kind of like the previous one. So this is the left hand side, p by q whole to the power 3x plus 2. Okay. And here q by p whole to the power, I am taking 1 minus common from this power only. So minus x minus 2 we can write. Okay. Now this is a negative exponent because this minus is present. So by the formula you can write that 1 by q by p whole to the power x minus 2. Okay. Now again this left hand side is same. Now for this term, now here you think by yourself that if I write 1 by q by p whole to the power x by 2, can we write that? Because this term and this term exactly same, because you just think that 1 to the power x by x minus 2 is just 1, isn't it? 1 to the power anything is always 1. So I can write this as this by the formula 4, isn't it? So you just think, if you break this term, it will be 1 to the power this divided by q by p whole to the power x minus 2. So 1 to the power this is again 1. Okay. And so see, these two are matching, isn't it? So this is the trick. Now p by q whole to the power 3x plus 2 is equal to, now 1 by q by p, it will get flipped. So p by q x minus 2. Okay. Now I applied these kind of tricks because I want same base in the left hand side as well as in the right hand side. So that's why I am applying these kind of tricks. Okay. Now the base are same. So therefore you can straight away write that 3x plus 2 equal to x minus 2. Okay. Now for this will be 2x and then this will be minus 4. So x will be minus 2. Thanks for watching. Please like and share this video with your friends.